Daniel Bernoulli helped found mathematical physics. In hydrodynamica, he related pressure, speed, and height of a fluid, what we call Bernoulli's principle, explaining lift and flow. He linked probability to utility in economics and worked on vibrating strings with Euler. Fun fact, Bernoulli's family included multiple generations of star mathematicians. Leonhard Euler reshaped analysis, number theory, and mechanics. He popularized the symbols E, I, and F of X, developed infinite series, and united geometry and algebra through Euler's formula. He advanced graph theory and continuum mechanics. Fun fact, after losing his sight, Euler dictated more papers than most see in a lifetime. Joseph Louis Lagrange recast mechanics with the principle of least action and Lagrange equations, turning physics into calculus. He developed Lagrange multipliers for constrained optimization and advanced number theory and celestial mechanics. Fun fact, his Mécanique analytique contains hardly any diagrams, only analysis. Pierre-Simon Laplace unified celestial mechanics, explaining planetary motion and stability with calculus. He founded Bayesian probability ideas and transformed differential equations and potential theory. Fun fact, Laplace's nebular hypothesis imagined the solar system condensing from a rotating cloud. Adrien-Marie Legendre refined least squares, advanced number theory with quadratic reciprocity, and introduced Legendre polynomials used across physics. He influenced the prime number theorem's early form. Fun fact, his geometric textbooks trained generations of students. Joseph Fourier discovered that complex signals can be decomposed into sines and cosines, Fourier series, while studying heat flow. His idea launched harmonic analysis and modern signal processing. Fun fact, Fourier loved Egypt so much after Napoleon's expedition that he filled his rooms with Egyptian artifacts. Carl Friedrich Gauss transformed number theory, analysis, statistics, and geometry. He proved the fundamental theorem of algebra, developed least squares and the normal curve, and mapped fields and surfaces. Fun fact, teenage Gauss famously summed 1 to 100 in seconds with a clever pairing trick. Augustin-Louis Cauchy brought rigor to analysis with limits, continuity, and convergence. He formalized complex function theory and solved problems in elasticity and optics. Fun fact, Cauchy wrote more than 800 papers, making a library of his own work. Nikolai Lobachevsky created non-Euclidean geometry by altering Euclid's parallel postulate. His geometry opened new views of space, later echoed in relativity. Fun fact, Lobachevsky's ideas were initially mocked, then recognized as visionary. Niels Henrik Abel proved the quintic is not solvable by radicals and advanced elliptic functions. He died tragically young, yet his notebook changed algebra forever. Fun fact, the prestigious Abel Prize is named in his honor. János Bolyai independently developed non-Euclidean geometry, warning that he had created a new universe from nothing. His appendix shocked mathematicians of the time. Fun fact, his father, Farkas Bolyai, urged him to avoid the topic. He didn't. Évariste Galois founded group theory to study polynomial equations, defining symmetry as the key to solvability. He wrote furiously the night before a fatal duel. Fun fact, his last letters sketched ideas that launched modern algebra. Karl Weierstrass rebuilt analysis on epsilon-delta rigor and produced counterintuitive examples like continuous nowhere differentiable functions. He influenced generations of analysts. Fun fact, he began as a school teacher, developing deep results in his spare time. Arthur Cayley helped found modern algebra, developing matrix theory and the Cayley-Hamilton theorem. He explored higher dimensional geometry and invariance. Fun fact, he published more than 900 papers while maintaining a legal career for years. Bernhard Riemann revolutionized geometry and analysis with manifolds, Riemannian metrics, and complex integration. His zeta function inspired the Riemann hypothesis. Fun fact, Riemann's 1854 lecture reshaped how we think about space itself. Richard Dedekind grounded arithmetic with ideals in number theory and defined real numbers via cuts, clarifying infinity and rigor. Fun fact, his correspondence with Cantor helped shape set theory. Dürr Cantor created set theory and the arithmetic of infinity, distinguishing sizes of infinite sets and introducing cardinal and ordinal numbers. Fun fact: his diagonal argument remains one of math's most elegant ideas. Henri Poincaré bridged topology, celestial mechanics, and dynamical systems, discovering sensitive dependence that foreshadowed chaos. He clarified special relativity's mathematics. Fun fact: he wrote lucid essays that made complex ideas accessible. David Hilbert set the agenda with his famous problems, axiomatized geometry, and advanced functional analysis in physics. His formalism shaped 20th century foundations. Fun fact: his phrase, "We must know, we will know," became a rallying cry for mathematicians. Henri Lebesgue reinvented integration, allowing functions too rough for Riemann's method. Lebesgue measure and LP spaces power modern analysis and probability. Fun fact: his work underpins signal processing and Fourier analysis today. G.H. Hardy advanced number theory and analysis and championed pure mathematics. With Littlewood and Ramanujan, he proved deep results on primes and partitions. Fun fact: his famous taxicab visit to Ramanujan led to the number 1729's legend. Emmy Noether transformed algebra with ideals and rings and connected symmetries to conservation laws in physics through Noether's theorem. Fun fact: her Göttingen lectures drew students from across disciplines despite barriers she faced. Srinivasa Ramanujan produced astonishing formulas and identities in number theory, Q-series, and partitions, often from intuition. With Hardy, he revealed deep modular patterns. Fun fact: many of his notebook results still inspire new research. Stefan Banach founded functional analysis, defining Banach spaces and transforming integral equations and PDEs. He co-led the Lwow School with a culture of problems in cafes. Fun fact: the Scottish book recorded their famous challenges and prizes.